Welcome back, everyone, to Application Security Weekly. I am here with Keith Hoodlet from who works for BugCrowd, and is my go-to source for application and application security topics. And so we decided to do a show, and I'm excited to talk about a bunch of news articles as well as some learning topics and tools. Let's start there and talk about what is hacksplaining.
Sure. So Hacksplaining is a neat website. It's free. You can just sign up on it after you go through kind of the precursor free open. I guess articles is not the right thing, but modules is maybe the right word here. Basically, what they do is they allow you to go ahead and just kind of walk through what are simple examples of different vulnerability classes, whether that's SQL injection, cross-site scripting, clickjacking, and a lot of others. And from there, those lessons go through not only what it is and how it actually comes about or how it exists in an application, but then they go into like a write-up of how that might exist in the different sets of code that it could be presented in. So once you've gone through the example, it will then have you go ahead and look at, okay, if I have Python, how would a SQL injection take place and how could I mitigate this? If I'm writing in Ruby, if I'm writing in Java. And so it actually goes ahead and gives you examples of bad code versus good code. And then at the end, it has like a brief 3 or 4 question quiz so that you can complete the module. What's really nice about it is it's free. So basically, you can go through the initial 4 lessons on SQL injection, cross-site scripting, command execution, or clickjacking. If you like it, go ahead and just sign up, and you can continue with the rest of the lessons. It's very informative, and especially from the development side, it's really kind of nice.
Sweet. I'll have to check it out. Burp Vulner Scanner. That's what it says.
So this, this is a little bit dated.
It's not a typo. It's not a typo. This is
nope.
This is an actual GitHub project.
Yeah. So this is it's a little bit old, about 6 months old now. But I like to point it out because they recently released, and I put this in the show notes for the news section, an Nmap plugin that does exactly this, which is it's a scanner that identifies vulnerabilities based on responses of the server. And what's nice about for an application security standpoint, if you're running different versions of, say, IIS is the big one that I always see, and that's part of the response back from the server for the web application itself, it will tell you the different CVEs and their CVSS scores for those different vulnerabilities that exist. So whenever I'm doing application security research in my free time, what I'll do is I'll go ahead and crawl the website accordingly, and the Burp Vulner Scanner will start to collect and aggregate based on information that is responded back to from the server, potential vulnerabilities that might exist in that application that I should pursue and test further. So a good example is I think it's IIS 7.1, and I could be mistaken. I'd have to go back and look at this appropriately, but it has an Ftp upload vulnerability that allows you to, I believe, upload beyond a specific size and potentially denial of service the application based on a very large upload, for example. So the Burp Vulner Scanner that has now got an Nmap plugin associated with it for the Nmap scripting engine, I believe, is something that I use as part of Burp, but also you can now use as part of Nmap as well for identifying those server-side vulnerabilities.
Sweet. And, of course, the Sans poster.
Yes. So this Devops Toolchain poster, and I imagine that this is going to give guidance to a lot of what we're going to talk about here on Application Security Weekly, goes through the entire development chain for DevOps. So it talks about a lot of the different tools that exist, and then, of course, where they fit in the life cycle of development. So you've got your pre-commit, and then, of course, there's a whole threat modeling or security and privacy stories, pre-commit security hooks, and so forth. So different tooling that's available. Commit, acceptance, production, and operations. And if you're in any one of those different stages as an engineer or as a developer, you probably are using some of these tools already. Like I'm looking right now at the acceptance section, and you've got immutable infrastructure like Docker. So having different tooling that's available to you from a security scanning as well as from a development side is really nice to just have a consolidated list. I was talking about this with my manager, Jason Haddix at BugCrowd, and he asked, where can I get a poster size of this that I can hang on my wall? And I said, I don't know, but I also would like one, and I think that's something that would be great for your developers as well, Paul, there in studio. So,
yeah, absolutely. We're going to get some of those posters. I know some people at Sans, so.
Perfect. And yeah, I'll be sure to get one of these hanging up so I can put it in the background here for maybe the next show or what have you. So
Yeah, that'd be awesome. All right. What do we got in the news?
I was going to say, I want to jump right into one of the things that I found somewhat telling about the industry that exists today, which is that companies are actually starting to design their own courses to train their hires on new technologies that exist. Basically, what is happening is companies like Microsoft, Amazon, Google, and what have you have found that even some of the best schools that are producing computer science or software engineering graduates are not preparing the new developers adequately for what they're ultimately using today, which is, again, that DevOps cycle and a lot of those tools that are in the SAN Secure DevOps toolchain. And so what is happening is some schools are starting to do more of like an edX model supplemented with in-class lessons and assistance from teachers, where effectively we're moving so fast in terms of new developments, new infrastructure as code, new features that exist in terms of the whole development lifecycle. And because of that, schools just can't keep up. And now we're seeing this really great article on how some schools are starting to integrate with large companies like Microsoft to take the actual lessons that Microsoft has produced and put them right into their curriculum, which I think is awesome. But at the same time, it's somewhat telling that maybe we have education as a waterfall model, and we're starting to see the rise of DevOps in education, which is companies building the courses that they actually need their engineers to know.
Yeah, I like that a lot, actually, customizing it.
And yeah, I mean, I think it's great, and there's a lot of available education out there. IT Pro TV, for example, is a lot of really great courses, and I'm actually looking forward to checking out their Vue.js course, which is a new JavaScript framework that does a lot of really interesting things, and I've heard a lot about. The next one that's actually in the news, though, and it's been somewhat eclipsed by the latest Intel and CPU architecture vulnerabilities, is a Mac OS 0 day that was dropped on December 31st, right around 5 p.m. Eastern, if I'm not mistaken. It goes by the name IO Hideous, which is basically it's part of the IO HID family, or Input-Output Human Interface Device family of libraries that exist in Mac OS. And it's ultimately the write-up itself, and if you get a chance to go look at the show notes, this write-up is very deep, very technical, but it's really beautiful because it talks about a memory corruption flaw that exists where the library that itself that is ultimately vulnerable and looks to have been vulnerable since about 2002 basically points to a specific segment of memory that may have a changing size. And so as a result of that vulnerability being introduced, an unprivileged user, so someone that's just a normal user on a local device, could ultimately get kernel memory execution, so both read and write. And at that point, they can get privilege escalation and they own the system. So the reason that this was dropped publicly as a public disclosure, according to the actual researcher that discovered this, was it wasn't remotely executable, and Apple doesn't have a bug bounty program on Mac OS. So because of that, they said, you know what, I'm just going to go ahead and release this. And they actually did a very, very nice write-up of how this all happened and proof of concept and the whole works. So definitely hats off on this one. I think that in terms of the Pony Awards for 2018, best research could very well come down to this, or of course the Intel CPU vulnerabilities that have recently been disclosed as well.
Keith, why doesn't Apple have a public bug bounty? Do they have a private bug bounty on Mac OS? It's just not public? Is that the deal?
So my understanding is they actually don't have a bug bounty on Mac OS at all. So again, this is something that was talked about a lot with the root vulnerability or the no password vulnerability that existed a couple of weeks ago, or maybe that was about a month ago now. Mac, or Apple, I should say, has an iOS bug bounty program, and I believe that's invite only, if I'm not mistaken. So it's not necessarily private in the sense that it's not like, publicly disclosed. It's public. I think it was announced at Black Hat a couple of years ago, but it is invitation only. The payouts are pretty high from industry standard for bug bounty programs. But again, when you look at things like the black market for iOS vulnerabilities, kind of pale in comparison. So I'm not sure why they don't have a Mac OS bug bounty program or even a public disclosure program of some kind. I think that's something that they've been encouraged to do time and again, especially in light of recent events. So who knows? I mean, maybe this will come about as a result of the 0 day being launched. Maybe not, because it's been overshadowed in the news and not a lot of people have been talking about it.
So now what's going on with the CPU design flaw? There's a lot of people talking about this, Keith.
Yeah, and in fact, so last night on Pulse Security Weekly, I talked about this a little bit, and I actually got the vulnerabilities mixed up a little bit. So let me make sure I make a correction on that, which is the meltdown vulnerability, which is a vulnerability that exists in CPUs such as Intel, ARM, and potentially AMD as well. It is all about basically what's the right word for this? Speculative execution, which is an optimization feature that exists in CPU architecture. More or less what happens here is the actual code that's being run at the CPU, it says, okay, I believe that, and I should actually make a correction right here. So Meltdown is specific to Intel. Spectre is potentially Intel, ARM, and AMD. Mm-hmm. So Meltdown is Intel privilege escalation and speculative execution allows basically an unprivileged user to read kernel memory from user space, which is potentially a vulnerability that could affect cloud infrastructure, shared hosting infrastructure. And what this means is, ultimately, if I am able to go ahead and get some sort of Intel privilege escalation, the speculative execution is a CPU optimization that allows for the CPU to pre-compute the predictive path of code execution that it anticipates taking place. It then will cache that code execution results. And from there, if that branch actually does execute accordingly, it's already done. It's already done the work for you. But if it doesn't, it has to kind of roll all of that back. And ultimately, this vulnerability leads to the ability for an individual to read kernel memory from user space as a result of that bad execution path caching the memory in a way that is not safe. And so from there, basically, if you're in a shared hosting environment, I have code execution on the AWS or the Azure instance that I'm using because I'm a privileged user to that end. So I'm allowed to go ahead and have code execution there. If I can read kernel memory, then I have the potential of being able to then execute code or even read code, I should say, in other memory spaces along that shared host environment. So that's where the cloud architecture problem comes into play. Spectre, on the other hand, is a branch prediction and speculative execution vulnerability. So effectively, if you have branches of code that may execute in different ways, and then speculative execution runs down that predictive branch accordingly, it's the same sort of problem, but it's slightly different in the sense that it's not tied to a privilege escalation in Intel. It's, in this case, predictive analysis of where the execution is going to take place, and then using that speculative execution vulnerability to then leverage code execution, which allows you to go ahead and read contents from memory of other users running programs. So both of them are tied to really what should be considered flaws in shared hosting environments. Of course, it could be something that someone executes locally on your system itself if they're an unprivileged user. But I think the real scare here is we run this thing called the cloud these days. A lot of companies are leveraging it. And to the extent that both of these vulnerabilities have potential issues that need to be addressed is no small thing. Thankfully, and I think that the thing that should be said here is large companies like Amazon, Google, Microsoft with Azure have probably a faster response time than I think any other smaller company is going to have when it comes to making sure that patches are pushed on this. And so to that end, people should definitely go ahead and perform any sort of local mitigations, because this is actually something that is a potential flaw from like the browser side. So for an individual user, JavaScript can execute these vulnerabilities locally to your system. So there is guidance out from Mozilla, there's guidance out from Google on how to go ahead and mitigate this with impending patches anticipated to take place for those specific browsers, as well as, of course, patches at the operating system level from, in this case, Apple, from Microsoft. I imagine that the Chromebooks have probably had patches pushed, given that, of course, Google's Project Zero is the ones who ultimately found this and disclosed this to Intel ultimately, and then I believe onto ARM and AMD as well.
Awesome. That's a great description.
Yeah, we have a lot of stuff on this too. So if you want more, go look at the show notes. Postgres is talking about how they leverage speculative execution and anticipate some slowdowns in the way that the database the integrations with the database or interactions with the database take place. So there's a lot out there on this, and this is very new. So stay tuned on probably more from this.
You had a link in there also from the vulners.com GitHub repository that ties Nmap basically. Again, I've been reviewing the code while trying to listen to Keith talk at the same time, and I suck at multitasking. It looks like it's taking the version string from an Nmap scan and comparing that to some kind of feeder database of all published CVEs to give you back a list. I just want to caution people that while that's a nice quick check, that leads to, in my background working for Tenable for 7 years, a ton of false positives and false negatives, just because of the way that software produces that version string. As an example, most Linux distributions will backport patches and not update the version number. So that leads to a number of different false positives, which is why many vulnerability scanners have to actually test for the vulnerability rather than just rely on the version string. Although it can be a nice, quick little check. I just wanted to point that out.
Yeah, this is definitely a good place to start. I think it's, again, not a free solution that's going to replace anything that you might otherwise use in the enterprise today. But to the extent that it is a good place to start looking for potential problems, and in correlation with other information that you may have, you can then start to discern what's a true positive versus false positive or false negative. And to your point, Paul, there's a lot of different tool sets out there today that allow you to even do patching in memory for Linux, whereby you're not even necessarily backporting the patch, but the patch has been applied in memory for that library, and there's no way that a scanner is going to even detect that that exists. So yeah, potential for false positives there. Definitely got to follow that up with some actual hands-on work to make sure that you're not just pushing out a report that says, yeah, they were vulnerable or not vulnerable to all these different things.
Yeah, I think it's a good individual kind of script to run against a single host or application to, as a check to say, these are some potential vulnerabilities you might want to look out for.
For sure. Did you want to move on to the Wi-Fi miner or the Starbucks Wi-Fi mining?
Yeah, let's talk about that. I think that's... Well, it's interesting because we were talking to Marcello last night on Paul Security Weekly about injecting JavaScript in via Wi-Fi, which I just think is really cool.
Which is exactly what this problem is in this case. So ultimately what ended up happening is someone notified Starbucks that their Wi-Fi at their Buenos Aires, one of their Buenos Aires locations, was causing a 10-second delay when they connected to Wi-Fi, and was actually injecting JavaScript into some of the requests to do Monero mining for that Wi-Fi connection as they were connecting to for that connection as they were coming onto the Wi-Fi. And so ultimately what ended up happening was Starbucks looked into this. It looks like it was actually the ISP, or supposedly it was the ISP, that was actually injecting this JavaScript into the requests accordingly, which is pretty concerning considering an ISP probably is doing this for a lot more than just that Wi-Fi at Starbucks. But it's a situation where, again, we've come to a point in time where Bitcoin or even cryptocurrencies are a huge deal, and there really are moving markets. I think Monero, according to this article, was valued at something like $300 and has risen over 1,500% in the past year. So the fact that we're probably going to see more of this, not less, is a reality that from this article we're starting to see. And in fact, someone actually took this whole concept and built out a proof of concept, which is another link in the news that we've continued to include as well, which shows that this is actually not only possible maybe from the ISP, but also possible from like a Wi-Fi location itself on a real Wi-Fi network. So we've included that in the show notes as well.
Now, how did they get the code to inject over the open Wi-Fi? Is that a physical location? Like, did someone physically go to the Starbucks and drop a device off, or like how are they injecting the JavaScript?
So I'm wondering if this is some sort of like, I don't know if it's necessarily header related, but as the ISP, they control the upstream requests that are being pushed around. And so if the connection to that Wi-Fi hotspot for connecting to it itself, so you have an open Wi-Fi, you connect to it, you go to log in, it's probably going to have some sort of like, I agree to the terms and condition button.
Oh, and that's where the JavaScript, Yeah.
So that might be ultimately where if that page is not necessarily HTTPS enabled, they could be injecting that into the upstream requests, especially at the ISP level. So they can say, okay, cool, you're making this request up to this page, or the ISP that's serving it, so we're going to inject this directly into your request as it goes upstream in a somewhat seamless manner, which is, I think, where the problem lies. It's similar to, I think, what a lot of people have been concerned about in the last few years to zombie cookies. So companies like Verizon, I think, were called out on this, where they were injecting cookies into requests so that they could track all of your behavior online in a way that couldn't be mitigated from the user end. So it's definitely something that, with the whole rise of cryptocurrency, again, being another application security problem that we're facing, we're probably going to see more of this. So I imagine we're going to have a lot more articles on this over the course of this year.
Awesome. What else we got?
So I know that we're probably looking at wrapping up here soon. There were two articles that I definitely wanted to cover for this episode segment. One of them is called the 100x Engineer. And it's not necessarily about tooling or about individual knowledge in terms of like knowing a specific language, framework, or library. But what it does talk about is it talks about how we go from being engineers, not only from like the software development side, but also I think this is more applicable today to security engineers, which is how to make yourself have 100 times the impact that you otherwise might have at your organization. And toward the very end of the article, they talk about a few very specific things that, beyond just technical know-how, I think are valuable. The first of which is communication. So knowing how to effectively communicate with your development teams, which is something that we hope to enable our listeners on, as well as being able to effectively communicate the importance of findings or of practices internally, is something that allows you to have an impact beyond just yourself. You can go ahead and have influence over the ways in which things are designed, for example. There's also creativity. So that's something that I think is necessary for just about every security individual, regardless of being in application security or otherwise. So being able to think beyond the problem itself, but come up with creative and in this case, hopefully also secure solutions to a problem in a way that is fluid and makes sense. Of course, the last three here, empathy, I think is probably the most important. Of course, we often look at the developers or look at the users and say, why did you do that? But at the same time, I think that to be effective, having that state of empathy with the individuals that you're interacting with and understanding the problems and the deadlines and the stress that they're under allows you to be more effective with your communication and with the ways in which you bring about or address problems that might be coming into play. The last two, negotiation. So in this case, being able to negotiate a minimal viable security, as Michael Santarcangelo would like to say, to be able to bring them to a state of good enough without letting good enough be the enemy of perfect, or in this case. And then lastly, of course, technical. You have to really understand or know what you're talking about to be respected and treated as having a seat at the table. If you are just throwing around buzzwords and you don't know what any of them actually mean, you're probably going to lose that credibility pretty quickly. And then from there, you're going to lose influence and so on and so forth.
This book I'm reading is so good that I almost don't want to tell everyone about it because I want the upper hand by being the one who's read the book. But when we talk about empathy and negotiation, the book I'm currently reading now that we've talked about on Startup Security Weekly, which is now Business Security Weekly, where we talk about these topics in depth, Keith, is called Never Split the Difference from Chris Voss. We're working on getting Chris hopefully to appear on our Business Security Weekly program. Like the best has helped me so much in so many different aspects, specifically with some of the situations you've talked about. Chris Voss was the FBI's lead international hostage negotiator and has gone on to teach classes in business that apply those techniques he learned in negotiating for hostages into some lessons for business, and also talks about the exact same things you're talking about, Keith, in terms of empathy and negotiating and how that plays in a business setting, whether you're negotiating for a team to implement a security project or whether you're negotiating for a position at a particular company or an increase in salary. And there's tons of different stories that Chris shares from his students that say, I learned from Chris and I applied this to my career in this way. So it's really good. Never Split the Difference by Chris Voss.
Awesome. Definitely going to add that to my Kindle reading list at this point. So I've added a few books recently. I intend to do a little bit more reading this year, which I already do a lot of anyway. So I'm definitely going to be adding that. I know that we're getting close to wrapping up here. Did you want me to cover this last article a little bit as well?
Yeah, sure. One more. Let's do it.
Sure. So, interestingly, UpGuard had an article that came out basically saying that millions of American households were exposed online. So, Chris Vickery at UpGuard wrote a really good, or found basically an open S3 bucket that had detailed information on, in this case, I think it was 123 million American households. And so, to that end, the details of the information that was actually disclosed on this database was all sorts of nitty-gritty information that would allow for effectively someone to have their identity stolen. Maybe not things like social security numbers or birthdays, but enough information about maybe where they've lived, maybe things that they've recently purchased, all sorts of like little minute details that could be a problem. The most interesting part, I think, about all of this, though, was the reason that this vulnerability came about was the AWS S3 bucket was configured with permission settings to allow any AWS authenticated user to download its stored database. And ultimately, what ended up happening was the individuals that set up this database thought the AWS authenticated user was an AWS authenticated user within their virtual private cloud. And this is kind of the heart of application security, is thinking about the ways in which even something as simple as UI UX can affect the security of infrastructure that you're rolling out. I had a great conversation with Gwen Betts at Command, which is now owned by Rapid7, at this past DEF CON 617 about UI UX and the importance and value of having that done right in an organization. And this is a very clear example of thinking about the security implications of something as simple as a setting and the UI UX of establishing a database. So I'm sure we're going to talk about a lot more of those sorts of things this year. But again, I thought that this was a great article. Again, Chris Vickery as well is a hound dog for OpenS3 buckets. And he's bound to find more this year, I'm sure.
And Gwen is awesome too. I also know Gwen and think she's awesome. So that's cool.
Yes, I agree.
We'll have to get Gwen on the show.
For sure. I agree with that 110%.
There you go. Gwen, if you're listening, we want you on the show. How about that? Keith, thank you so much for putting together this edition, this first episode 000 of Application Security Weekly. Thank you, everyone, for listening and watching. We'll see you next time.